All right, in this explainer, we're going to crack the code on a pretty tricky GCSE exam question. I'm going to show you how you can lock in every single mark. And the secret? Well, it's all about learning to think exactly like an examiner.
So, how do we actually do that? We're going to dive right into a real GCSE question and use the official mark scheme pretty much like our own treasure map to find every single point that's up for grabs. Okay, so our challenge today is question 04 from a higher tier paper. The whole point of it is to use chromatography to figure out the colors inside 3 different flowers. You know, just A, B, and C.
Right off the bat, the question gives us a massive clue, a clue we just can't ignore. The colors dissolve in ethanol, but are insoluble in water. This is so important. Let's see how the students set up their experiment. And, oh boy, where they went wrong. The first part asks us to find 2 mistakes the student made and then explain the problems they cause. This is a classic format, right? You see this kind of thing all the time. So let's get a look at that diagram of their experiment. All right, so take a really good look at this setup. You've got the beaker, the chromatography paper, the little spots for A, B, and C. Now, before I just give you the answers from the mark scheme, why don't you pause for a second, see if you can spot what's wrong here. Okay, the first mistake is a total classic. The start line was drawn in ink. Now, the mark scheme is super clear on this. You get 1 mark for just pointing out the mistake, but you get that second crucial mark for explaining why it's a mistake. The ink itself is going to dissolve and run right up the paper, mixing with everything and completely ruining your results. So the number 1 rule here for getting full marks is this. You always use a pencil for your start line. So why a pencil? Well, the lead is graphite, and graphite is inert. That just means it won't react or dissolve in the solvent. It's just going to sit there and not mess with your experiment.
And the second mistake, well, it takes us right back to that massive clue we got at the start. The student used water as the solvent, but we were told the colors are insoluble in water. So what happens? The colors won't dissolve, which means the spots are just going to sit on that start line and go absolutely nowhere. Yeah, the experiment is a total bust. Okay, now that we know what not to do, let's look at an experiment that was actually done correctly. For the next 2 marks, our job is to look at these results and pull out 2 clear, solid conclusions.
And here it is. This is a perfect example of a chromatogram that actually worked. You can see the spots for A, B, and C have all separated out nicely. So look closely. What 2 things can you say for sure just by looking at this?
So what's really cool is that the mark scheme gives you a few different options, and you only need to pick 2 to get those marks. For instance, you could say that flower C has to be a mixture because its spots separated into 2 different colors. Or you could say that the color in flower B is the most soluble. How do we know? Because its spot traveled the furthest up the paper. Super simple. Literally any 2 from this list, and you've got the points in the bag.
And finally, we get to a 2-mark calculation. This is a fantastic chance to scoop up some easy marks. But the catch is, you have to remember the formula, and, this is the most important part, show you're working. Okay, first, let's just quickly remember the formula. The RF value, it's basically a ratio, right? It's the distance the colored spot has moved divided by the total distance the solvent has moved. Now, this question has a little twist. We're actually given the RF value and the distance the substance moved, and we have to find the solvent distance. So to nail this, we're just going to follow 4 super simple steps. Rearrange the formula, pop in the values, do the math, and write down the answer. So to get that first mark, all you have to do is show your work. First, you just flip that formula around to solve for the solvent distance. That gives you substance distance divided by the RF value. Then you just plug in the numbers the question gave you. So that's 3.2 centimeters divided by 0.65. And once you punch that into your calculator, you get your final answer. And if you write down 4.9, that's what gets you the full 2 marks. And hey, if you really want to be perfect, don't forget to slap the units on there. Centimeters. So after all that, what's the big takeaway here? It just goes to show that getting full marks isn't only about knowing the science. It's about showing what you know in the exact way the examiner is looking for. Seriously, the best way to think about it is that the mark scheme is your checklist. For a method question, find the mistake, explain what goes wrong. Check. For a results question, make direct observations from what you see. Check. For a calculation, show every single step of your work. Check. And always read the question carefully for those little clues. See? By breaking questions down like this and really getting what the mark scheme is after, you can master pretty much any topic. Just remember, how you get the answer is often just as important as the answer itself.